Hi everyone, in this video I want to dive into the Model Context Protocol or MCP. We're hearing a lot about it today, so I want to dive into why, what does it do, and then some of the benefits we get from actually leveraging MCP. Now today we understand the idea that, hey, I want to create an application and I want to create a generative enabled application. I want to use a large language model. So today I would think about, okay, well, I'm going to write my particular application. And then we have that large language model instance that we want to use. So I've got some large language model, and I'm going to have interactions with that model. And that's fantastic. That's fairly easy to do today. But as we know, that large language model we're using, it was trained on a certain corpus, a body of data. So it has a certain amount of knowledge, but it doesn't understand anything that it wasn't trained on, anything past that cutoff date, anything that's my specific data or my company's data. Additionally, it can't interact or call other tools or actions. And so what we want to do is be able to give it additional capabilities via my application. So I can think there's other things outside of just the large language model in the application that I want to be able to use. I might have the idea that, hey, there is some service. It has certain capabilities that I would like to be able to take advantage of. I would like to be able to, for example, have some other data, some other knowledge. So there's some additional knowledge store I want to be able to use. Maybe I even have things local on the machine that I want to be able to go and tie into. So there's some other, maybe a file, for example, local on my box. And that's great. And if we think about what's actually going to have to happen typically when we use these things, is that me as the application, I would have to be able to do a number of different things. What I would have to be able to do is talk to each of these services. Now, each of these services, well, this has a particular API. This other, maybe a database, well, that has its own API. Maybe this local file on the box, well, that has some way to communicate. So either my application, maybe an orchestrator like Semantic Kernel or Copilot Studio, whatever it is, well, they have to be able to communicate with all of these different things. So my application here, I've got two problems. One is, well, I have to go and enable how to talk to this particular API. And I would have to understand how to talk to this API, etc., which I don't want to have to do that. But even after I plumbed in and understand how to talk to these services, well, the next problem is I now have to know, what do I tell the large language model to describe the capabilities of all of these different things so that it knows that they're available to it. It can then tell me, as the application that's calling it, hey, go and run this on that service on my behalf and then send me the result, which is the way these things work. When I want to plumb in additional knowledge, or I'm plumbing in tools that it can execute, could even be local, I, as the thing calling the large language model, have to describe, hey, these tools are available, describe this additional data is available, and then the large language model will say, hey, I need to run that tool. Hey, I need some more knowledge. Run this for me. I then have to go and do it and then call the large language model again with the previous history as the context and that new information. And so I would have to work out, what do those prompts look like that I'm adding to describe the capabilities of all of those different things. So that's a huge amount of work. This problem of connecting things together is not a new one. If we think back to the early days of computers, if you looked at the back of your computer on the motherboard, there'd be one type of socket to plug the printer into, another one to plug a mouse into, a keyboard into, one for your monitor, one for a modem. The list goes on. You had all these unique types of cable that were even specific to the type of machine, if it was a PC or Mac. So that was a nightmare. Well, we solved that with a standard. For physical devices, today that's USB-C. That describes both the way they can connect and it describes how they can communicate. So the protocol and the actual connectivity. And what we want is the exact same thing for our AI applications to be able to go and leverage the other tools, the knowledge, information, templates that can empower our large language model to be that much more powerful and useful. Hence, the Model Context Protocol, or MCP. This is defining a standard way for my AI application to have interactions with all of these other types of other service that can help give my large language model additional context in that standard way. Now, the way this is going to function is a client-server architecture. Now, here in this example, we have 3 different things that my AI application may want to talk to. And what will happen is my application is going to have created a local client object, an instance of an MCP client, as part of the application. So I can think, okay, I'm going to have, because there's 3 different things I want to talk to that are all going to be MCP enabled, I'm going to create one MCP client instance that's going to correspond to this one. And I'm not going to write MCP client out every time, but there's be another instance of the MCP client here and yet another one here. And so this all becomes part of my little application. So I have 3 MCP clients, and there's always going to be a one-to-one mapping between an MCP client instance and a particular MCP server that represents a particular instance of a service I want to talk to. So in this case, hey, I'm also going to have an MCP server that is a server specifically for this type of service. That's MCP server A. I would then also, for this particular API, well, this time I'm going to draw it over here. I'll explain why in a second. So I'm going to have another MCP server, and then another one for this particular file. So there is a type of MCP server for each of the different types of service I want to be able to talk to. And this is important because remember, this service spoke the Orange API. So what's going to happen is the MCP server for this service speaks and understands that particular API. The MCP server for this particular type, in this case a database, well, it speaks that particular API. And then this resource down here, well, this type of server understands how to talk, for example, to these local files. So there's going to be a specific MCP server for each type of service. There'll be a Postgres MCP server. There would be a GitHub MCP server. And then what they're all going to do is they speak from the client to the server, the MCP protocol. So the MCP client, I just have 3 instances of the same client object. It just speaks MCP protocol. And what the MCP server doing is, you can imagine on one side, it speaks MCP. On the other side, it speaks whatever the native protocol is for the particular type of resource or tool that is an MCP server for. So it's a layer of abstraction that now the client doesn't need to understand any of these details. It just has to speak the MCP protocol. And you can imagine this is also beneficial because if I'm this service, for example, and I wanted different types of AI solution to be able to talk to my service, well, before I would have to maybe create lots of different plugins for my service. Now, I just create a single MCP server implementation for my service, and then any AI app or platform that speaks MCP can now talk to my MCP server that I'm creating and making available. So instead of creating maybe tens or hundreds of different plugins for my service, I just create a single MCP server. Now, one of the things you'll notice I drew out here is, well, one of the MCP servers I kind of put over here, and then another one I put here. And you might be wondering, what is this distinction? And I might think about, well, this is actually the local machine. So I could think this is the local box. Because the MCP server can actually run locally on my machine. Now that would make complete sense if the resource was local on my machine. And in this case, where it's local, it's just going to use standard I/O for the communication. But the resource may be remote. Now, if it's remote, it can use HTTP post operations to talk to the server, and then it would use server sent events, SSE, to talk back to me. But what you're going to find today is most of the actual MCP servers actually run locally. Even if the service is remote, you're still going to, and these companies make it available, I still run the MCP server component, typically in an isolated, a sandbox type container, locally in my environment that then the client talks to. And the reason for this is a very new standard. And one of the challenges today is when I think of security, when I think of authentication, that is still something that is largely being worked out, that's still being worked through the right way of doing that. And so the idea of a client talking to a remote MCP server, well, although, yes, it's possible, the authentication, the security around that is not well defined today. It's being worked on. They say almost the S in MCP stands for security. Right? There isn't an S in there. And so most of the time, you're not going to be talking to a remote MCP server. The service will provide you the MCP server for their service, and you'll just run it in an isolated process. So it's all local, and then that MCP server will go and talk using the existing mechanisms, for example, from a client to a database to that remote service. So just to understand, when we talk about MCP servers today, while in the future, I think we'll see a lot of this, where the MCP server will live with the service and be hosted maybe out there on the internet through TLS type encryption communications. Today, it's not that common. Today, most of the time, these people will provide you with the MCP server as an isolated little container, and I'm going to run it in my local app environment, but then my MCP service clients can communicate and leverage the service. So just understand there's that happening today. But the whole point is the MCP is abstracting away the specifics of what actually is required to talk to those services. So now my application just has to create these little client instances. I add in all the MCP servers that I want to talk to, and now it's just available to be used within my application, and it can go and talk to all of those different things. It makes it far, far simpler for me to do. Another really nice thing MCP gives us is reflection. Remember, there were two problems we had. One, my app had to learn how to speak all of these different APIs. The MCP client-server architecture protocol solves that. The second problem was I had to work out, what am I adding to the prompt I send the large language model to explain to it, hey, these tools are available to you. This knowledge is available to you. That was a challenge. Well, MCP also solves that with reflection. The MCP server itself, as part of the establishment of a session, there are key types of capability that the MCP server exposes today. So when I think about all of the things the MCP servers will expose to the client, and again, remember, it's going and talking to those back-end services to actually implement and perform the actions. Well, the first thing it can do is I can have resources. So I can have this idea of a resource. So a resource could be structured data. It could be documents, things that I might ask the large language model, hey, can you give me information or summarize the meeting? The large language model will say, hey, can you go and get me this data? Think retrieval augmented generation. I'm adding data to the prompt to give the large language model more information. So resources can be exposed via the MCP server. It can say, hey, I have these things available. It can also expose tools. So a tool would be a function that can be called to perform some action, maybe query some API. And it would explain, well, here are the parameters I want as part of that. Another thing it can give is prompts. So the MCP server can say, hey, here are some predefined instructions, some templates for specific tasks. It will help the application when talking to the large language model better craft the prompt that will give the best interaction back and then maybe go and use and get more information via this particular service. The MCP client has capabilities as well. One of the things you can actually do is something called sampling. The server can ask the client to run a certain prompt to the large language model on behalf of the server. So when I say, hey, go and run this for me and tell me what the response is. So there's a lot of really powerful capabilities here, but as you can see, the key ones often we're going to focus on are these resources and tools. Knowledge that I want to be able to have the large language model call on, and then tools, things I want the large language model to be able to say, hey, go and execute this for me. And remember, this is always via the app. The large language model can't go and look this up directly. The large language model can't go and call APIs. It always creates a plan and it asks the app to go and do these things for it. So when it asks the app to go and get some knowledge, the app now just says, hey, client, go and request this for me. Hey, client, go and run this particular tool for me. And that's the way they're going to get this. So when I'm writing my application, one of the things I'll now do is register the MCP servers I want to leverage as part of my application. Now, as part of that client initialization, it can specifically ask to tell me all of the things you're capable of. The server will respond, here's all the supported tools I have, the supported resources I have, the prompts I have. Or the client can just send a sequential set of list requests, tools list, resources list, prompts list, and it will receive a payload back. So I could think about, okay, well, for this service supports maybe tool 1 and tool 2. Supports 2 tools. Maybe this is a database. So it exposes a resource. Maybe it's explaining the schema of the database. And then sure, you can run select statements against it. So it exposes a certain tool. Maybe for this local file, maybe all you can do is it's a resource. I can just read it. So maybe this exposes resource 1, for example. So I have this idea that the MCP server will be configured with the tools, the resources, the prompts, that when the client asks it, hey, what can you do? It's going to reflect and tell it, hey, I've got 2 tools available. Hey, I've got a resource and a tool available. Hey, I've just got a resource available to you. And for each of those, it's going to give a payload that will have a name, a description, a JSON schema that outlines the required inputs you're going to need to actually use the tool. And you can see this. If we actually jump over for a second to like some of the sample code. So here we can see it's a very basic. So we're using, in this case, it's just the MCP library. We're creating a client session. It's using standard I/O. So it's the MCP server is running local. And it's bringing in the client. You can see it goes ahead. If we scroll down, it creates sort of the client. So it would create one of these for each MCP server. But we can see, hey, list the prompts. Then it even goes, and after it's got the list, how it can go and get a particular prompt. List all the resources, list all the tools. So we can go and ask it, what are the things you're capable of? And then later on, when it gets this list and it sends it to the large language model, or maybe the large language model says, well, actually go and read a resource. So now it can just say, hey, read a particular resource, or call this particular tool that it was told about before when it did that listing of the resource, when it did those listing of the tools. So it's really, really easy to go and leverage this MCP. If I was to look at an MCP server, this is a really simple one that just does time. So once again, we can see this is someone's written this. This is an MCP server for time purposes. So it's from the MCP server library. And if we just jump down, one of the things it has to be able to do is that reflection. And so they've created the ability to respond to the list tools. And it returns this array. So the tool, it has a name, so it has a get current time. It describes what it does. Then it tells it, what are the things you need to send me to call this tool? So it needs the time zone. Then it also has a second tool. Well, this is convert time. And then once again, okay, for convert time, it describes what it does. And then what are the inputs I require to be able to use this? And then later on, it'll have a handler for if you actually try and call the tool, as you can see here. So this is just an example of an MCP server, but you can see the way it's enabling that reflection capability. When I write an MCP server for my product, my service that I want to be part of MCP, I will enable the ability that it does the reflection. The client can ask me, what are my capabilities? I'll tell it the tools I'm going to expose. I would then, within my server, write the code. So now when I get that request over MCP, I then speak the native API to that service to actually make it a reality. I enable that. But I only have to write it once. I just have to now do this MCP server, and it can be used by anything that speaks MCP. If I was a database, I do an example here of it exposes a resource, and it has the ability to expose a tool. We can see that as well. If we jump back over, and let's go and look. This is an example of a PostgreSQL MCP server. Notice it exposes two things, a tool, and it's a query, and it has the description of what it's going to do, and it tells you what the input is. Then it has a resource, and the resource is the table schema. So for each table in the database, it's going to explain what that is. Well, obviously, having the schema will now help the large language model know how to best construct the SQL query it wants to execute, because now it understands, well, what are the various columns that I would want to be able to leverage. We could look at an example of a GitHub MCP server to go and talk to GitHub. This just exposes a whole bunch of tools. Create or update a file, push files, search repos, create repos. These would all be exposed. They all have descriptions, and then they all have the inputs, the schema of what a request would look like to actually go and use these. And that's what there is as part of this. And talked about, obviously, the prompts could be there as well. So the way this would all fit together, so let's sort of step through this. I, as the application, I had an array of the 3 MCP servers that I want to use. They've been stood up on my box, and they've been configured with this file to talk to this database, to talk to this service. When my program initializes and it runs through the 3 clients and they establish these connections, it will send that request. Tell me all of the tools, tell me all the resources, tell me all the prompts. So as part of that, as it runs through each of those, the application would now create its own local, probably a JSON array of all of the tools that are available. So I'd think about, okay, the application will create an array that's the sum of all of this. So we know there were 2 tools over there. So it would have tool 1, tool 2. We have the resource 1, the tool 1, and then it would have this one, the resource 1. So it would create this array of all of the tools, the resources, the prompts that it's been told are possible across all of these different servers. So now what it would do is when the application now wants to go and talk to the actual large language model, normally the way this would work is we just send the prompt. What we're going to do now, in addition to that, is it's going to send the prompt plus this array. I've structured the name, the description, the parameters it expects in my whole new array, JSON format. And now when I talk to large language models, say, hey, you're a helpful assistant. You're being asked to do this. Here's the list of all the things you can ask of me. Knowledge, tools you can run, prompts that might help you do the things. So now when the large language model is processing this, and large language models are really good at being told about, hey, there's other things that you can ask me to do on your behalf. If it decides it needs one of these, instead of returning the output, it will return a plan. And the plan will say, hey, I need you to go and run R1 and return me the result. So now the app would go and say, okay, well, R1, that's this one over here. Cool. Read resource R1. It would get the response back and now send a subsequent prompt with the previous one as the context of history. Large language model says, okay, great. Now I can go and perform the thing, return the result, goes back to the end user or whatever that target is. So this is the whole point of how this is working. The large language model itself knows nothing about MCP. Doesn't care. The large language model just sees the input, which happens to have an array of tools, and then it returns the output. It is the application or maybe an orchestration layer, if I'm using something like semantic kernel or whatever, it handles all of the MCP behind the scenes. Again, the large language models are really good at being told knowledge exists, actions exist, and you can ask me to go and do that for you. So that will all now just go and happen really behind the scenes. If you look at all of this, MCP is not doing anything I couldn't do before. It just makes it far, far simpler. Before, I absolutely, as my app, could just talk Orange API. And I could work out, okay, well, here are the key types of things I want to do. I will work out what prompt I'll add to describe those things. And then when it asks me to do it, I'll work out what the right API calls are to go and do that. I could go and talk directly Purple API. I could go and talk directly to this resource. But it's all work in being able to code to talk Orange API, Purple API, resource. And then it's all work to understand and maintain what are the capabilities that I need to describe to the large language model for me to then be able to go and do those things. So it's really simplifying all of those things. For the Microsoft people, obviously that's normally what I live in, MCP is fully being embraced. If we look at Semantic Kernel, Copilot Studio, GitHub Copilot, they're all very much jumping on the MCP train. Azure API Management. Azure API Management is often used today as an AI gateway set of capability. And I talked about there's pain today in having remote MCP servers because of the lack of the security, the lack of the authentication, the whole auth scheme. One of the things API Management does is fantastic at layering that security, laying the authentication on top of things. So API Management can help developers build these secure MCP servers using those existing authentication schemes. So that makes a lot of sense to just, hey, I already have my AI gateway. It can become my MCP gateway as well. Azure API Center can act as an MCP repository. There's already labs out there on trying out APIM with MCP. And just in terms of the overall, I think when you think of the gaps in the standard, Microsoft are working with the industry leaders, how we can think about improving the specification for the security, for the authentication, because I really think you have to get that nailed down to get that wider adoption for those remote MCP servers. Again, today, most of the MCP servers, they're going to be provided by these, but you're going to run them locally on your box until they get this remote server security and the authentication piece worked out. But it's going to get worked out. This is very early days for MCP. It's only going to get better. I think it's only going to get better in terms of the discoverability of the MCP components. But it makes it so much simpler now that, hey, I want to light up these tools, these resources for my AI application. And now it literally, just like the USB-C cable, it's plug and play. I can now just plug and play all of these services in where they provide me an MCP server. They've done that work to create it. Makes it really easy to now integrate it into my app. So I hope that was useful. And until next video, take care.